G'day, everybody. Well, look, this is very, very exciting. We have got the first episode, the audiophile series, and this is going to be done with my absolute friend and co-host, Louis V from Vinyl Lattes.
Hey everyone, welcome the Aussie audiophile community and Vinyl Latte community. Shane, let me just say, we started talking about this series months ago. I mean, it's got to probably be at least 6 months ago. And then we announced it about just before the holidays. And YouTube community has blown up about it. And everybody's been asking, when's our first video? When's our first video? Today's the day, my friend. And what a great topic and what a great host. So maybe you could be so kind to introduce everyone to who we have online with us.
Well, we have our absolute experts there at Stack Audio. We have Theo Stack, and we've got Josh, who is the front man for Stack Audio. We want you guys to meet these two experts in their field, and we're going to talk to them about some pressing questions that you guys would want the answers to. So I'll kick it off with the first question. In your experience, what are the most common misconceptions audiophiles have about isolation, and how do these misconceptions impact system performance?
So one of the most common misconceptions we find is, and I know you're very well versed on this, Shane, and you've done a recent video, and Louis' room is exceptionally well treated, is that isolation that can cure a badly set up room. We've recently been looking into this with my brother Dan. He's doing a bit of behind the scenes work on creating some documentation. But room interaction is so complex and it plays such a significant role in the sound quality that you experience. So a badly set up room, you have standing waves, poor bass response, and unwanted reflections. Whilst isolation will help to address these issues to a degree, it's essential that your room is fully set up first. And I know you've did quite a lot of work on your most recent series, and it's something that we've been investigating quite thoroughly recently. So I think that's a core one for me.
Yeah, look, I couldn't agree more. As you guys know, we've been talking a bit backwards and forwards about that and how it works and what have you, and part of that whole initial room setup is to do with making sure that standing waves are isolated so that they're not affecting your components. I mean, let's be honest, we've got these two big things on the side of the room that go backwards and forwards like this, create all kinds of air pressure and vibration. And if that is transferred through the floor and back up into our components, it smears time domain, It smears imaging. There are so many things that I hear in my system when the system is not isolated correctly. So it's a very good point, and thanks, Josh, for making it. I think that's a really good start.
I just want to also highlight something that Shane said, because somebody coming from the analog world, a big vinyl player, and vibrations is the enemy of a turntable as well. And I think it's key to keep that in mind of what you just said, Shane, that the speakers are in there. They're literally battling your turntable because all of those vibrations in the air are hitting that turntable, causing micro vibrations to come back, which can muddy your playback. And you can have the most expensive stylus or the most expensive turntable. You still have to worry about vibrations.
Correct. I completely agree. In fact, speakers are the absolute enemy of a turntable. So being able to create a barrier between the turntable and the speakers is absolutely paramount to really getting that full resolution that we can get from our analog.
Yeah, 100%. I think further to that, trying to move the turntable outside of the kind of energy of the speaker, so not having it right at the back wall or in the corner, that can also have a profound impact because it's not kind of being excited as much by the speaker's energy. So actually just changing the position of the turntable itself can definitely improve the sound quality.
Yeah, really good point. I know bass propagates in the corners of rooms. From my sound engineering days, it was one of the things about room acoustics. That sound will propagate and spin around in the corners of rooms, and you'll get air pressure changes and absolutely. I mean, anything really, but turntables especially are really susceptible to that.
Absolutely.
So, really good point there.
And I think in the 70s, Ivor, when he developed the LP12, he basically demonstrated the effect that sound waves vibration can have on the turntable by just taking the turntable out of the room and just running a long cable to the amplifier. And that was kind of a very easy way to demonstrate the effect of vibrations on turntables. I was going to say another misconception is that spikes isolate equipment, be it speakers or actual audio equipment, from vibration when used on a hard floor. So we've recently just done some tests where we basically had a hard surface and we had a speaker. We tried it with and without spikes. And what we actually found is when using spikes, it amplifies the vibration. And this is because with a normal, or not say normal, but when a speaker's placed directly on a hard floor without spikes, you've got the friction between the base of the speaker and the floor itself, and that helps dissipate the energy. Whereas when you have them on spikes, they're kind of concentrating that energy. So I think it's definitely become less of a misconception and people are understanding it. But I think that is a misconception. And to add to that, also using necessarily different solid materials will make a dramatic difference, because there's this thing called dampening. So basically how well material or the particles in a material absorb the vibration. And you look at the data sets for different materials, be it brass, gold, aluminium, steel, they're not drastically different. So changing the same spike to say stainless steel to brass, it's not going to make a dramatic difference. So everything has a difference, but immeasurably it won't be significant.
Yeah, I've always said everyone thinks spikes are a one-way street. It isn't.
Yeah.
It simply isn't. It's whatever can come out of that spike and also go back up through it.
Absolutely.
Very good point. From a technical perspective, what are some of the critical factors that make isolation effective in reducing microvibrations across different components?
So basically, when we talk about microvibrations, we usually refer to vibrations low in amplitude, so low in power. Whereas let's say with a speaker, you've got microvibrations, which are a problem, but you've also got kind of normal vibrations, which are kind of high in amplitude, so high in power. And those, when isolating speakers and also some equipment, are the main ones to focus on, because that low amplitude vibration kind of cuts through everything. It cuts through the floors, racks. So whereas a micro vibration, so let's say the surface of a record, whereas already it's pretty well isolated. So those are kind of micro vibrations. So whilst we use the same kind of technology and approach, they are slightly different. And an example of that is when you were developing the Serene stabilizer. One of our first prototypes was a metal body with metal particles. So basically an adaptation of the Alva for isolating records. But we found it didn't make a huge difference. And it was audible, but it wasn't like enough to be a kind of really special product. And the reason that is because those micro vibrations are low in amplitude. They're kind of hard to absorb or get excited by, say, traditional methods, be compliance or particle impact dampening. So then we adapted that technology. So we created TAPA, which is basically a tensioned membrane that kind of gets, once it sinks onto the record or the spindle, it then pushes up and creates this trampoline effect. And we used lighter particles to kind of excite from those micro vibrations. So basically, we just take different approaches. But micro vibrations are most prominent in turntables, whereas with speakers and equipment, it is, like I said earlier, it's more the kind of high amplitude, high power vibrations that are the most problematic, because those are the ones that reverberate through the room, whereas micro vibrations, when it's kind of dealing with that high energy, can be more manageable.
Yeah, I agree. Well, that probably leads me into my next question, which is, while turntables are often discussed, what role does isolation play in optimizing the performance of other system components like amplifiers, DACs, streamers, all those sensitive digital components, for instance?
Yeah, absolutely. So basically there's this term called microphony, which is essentially where external vibration will enter an electrical circuit. And And components, like for example, a crystal oscillator, it vibrates and oscillates. And if an external vibration enters that clock, it will cause it to deviate, which otherwise known as jitter in terms of the clock. So it's basically external vibration coming in and changing the characteristics of the components on a circuit board. And again, not to get too technical, but it's similar to sometimes the most sensitive vibrations to electrical components are those really big, powerful bass notes, because they cut through and they kind of just echo through the enclosure in the circuit board. There are a lot of reasons why it affects, or vibration can affect individual components, but the main one is it just deviates the signal. And I think also it's similar to cables. Like a lot of people report having tremendous performance increases from using different cables. And I think whilst the materials they use have a good impact, a lot of the time I think it's a cable's been well designed to kind of absorb vibration or dissipate vibration better, because these cables are running along floors, and essentially a similar principle, microphony, external vibration enters the cable, causing microphony.
Yeah, I mean, I've actually got my network boxes for my transparent reference cables sitting on 2 EQs. So
yeah.
I've got them up off the floor, and I heard a difference doing that.
Absolutely.
If you like, it just seemed to clean up the really micro detail in the presentation. It sort of almost lifted a weight off the presentation when I did that. It was that. I sort of sat there and went, that can't. Can I really hear that? And I took them back out and sat the thing on the ground and went, yeah, I really heard that. That does something. So 4 of them are underneath those 2 network boxes now, because they just,
nice.
You can't unhear that stuff. Once you hear the difference, you just can't go back. It's one of those things. And I absolutely agree with the whole thing about vibration getting into sensitive things like crystal oscillating clocks, because
Absolutely.
That's where and everyone's heard jitter, but sometimes we don't know what the cause of that jitter is. And I think that was really well explained, Theo, that sometimes we're not looking to think, well, the thing's jittery, so it must be a crap component.
Yeah, absolutely.
Not necessarily so.
Yeah.
That's a very fair point. And Shane, welcome to the speaker cable rising community. That I'm a person who's a fan of rising my cables off the floor and keeping them isolated from the floor. So welcome finally to drinking that drink and joining the community there, because it does make a big difference. Yeah, it does make a big difference. One of the questions that came through when I was reviewing one of your products was, how do you approach designing isolation solutions that actually complement systems and their existing acoustics without introducing unintended trade-offs or tonal shifts? And I'd love to get your theory on that, because I've tried many different isolation products in the market, and there always tends to be some sort of trade-off you need to do. And I haven't really experienced that with your Stack Audio product. So how does that happen? How do you make that happen?
It's a really good question. I mean, basically, in short, is to try and get as much broadband vibration absorption across the audio frequency. So by that, I mean, you don't want one set of frequencies to be higher than the others. So you're trying to kind of do as much of a balanced absorption across the frequency range as possible, because if you have one frequency range kind of spiking much higher, that's going to be the predominant frequency, and it could excite other similar frequencies. So in short, it's trying to isolate equipment across the full frequency. And again, it's the lower frequencies that are the biggest pain. They're by far the hardest to isolate, but it's that broadband isolation. And also with speakers, for example, we don't want to change the fundamental mechanics of a speaker. So for example, if we were to use a compliant solution like rubber, this speaker's been designed to be rigid, and it's been voiced whilst it's been rigid. So if we were to then make it kind of compliant and movable, we're essentially changing the characteristics. So it is trying to stick to the original manufacturer's kind of ethos and broadband isolation And also, like Josh often suggests to customers, like if a product uses 3 feet, then use 3 Alva EQs, because potentially they've designed it to be most stable using 3 feet. So it's trying to stay coherent to the manufacturer's principles whilst not allowing big difference in the frequency of vibration you're absorbing, broadband absorption. So I think that's the key to trying not to change the characteristics of equipment.
So it's basically isolating. It's looking at full spectrum and not just addressing the most problematic frequency ranges, which tends to be on the base size, the low end. That's where, and ignoring the rest of the spectrum. Is that where you kind of start noticing those tonal shifts and changes in the way that it's being this sound's being presented to you?
Yeah, basically you've just summarized it perfectly. It's just trying to, let's say you have a chart where all the frequencies and amplitudes are just jumping up and down. You kind of want to level it out as much as possible so there aren't any prominent vibrations cutting through the device, and so that essentially is I think the key to developing something that doesn't change the characteristic of the designer's original intent.
One of the things that I noticed about your speaker isolation is that apart from the particle dampening technology that's present, and that's the secret sauce that is different from others, is that you guys spike those footers. So I find that hugely important, especially with Wilsons, which are already adjustable in the time domain. Keeping that front baffle absolutely rigid must happen to get your soundstage and imaging right in focus. And you guys do that very, very well with those footers, as I noticed that straight away when I slipped them under there and adjusted the speaker. I heard an immediate improvement. When I spiked them and then sat them back down, I went, holy heck, like it was another level again, you know?
Of course, yeah. And just a little side note and tip is I think it's not often done, and understandably it's a bit of a pain to do, but it is to get either a digital spirit level or a machinist spirit level, and actually make sure that the speaker is perfectly level on both axes. It makes a difference. So it's just a little thing that's, if you've got a spare 5 minutes, that is worth trying.
Yeah, absolutely. Well, that again leads me into this very next question, which I think is a little bit of a teaser for what might be coming up. Hopefully you guys have got some info for us. But if you look ahead, right, and we're looking at advancements or breakthroughs in isolation technology, what do you foresee that might shape that whole industry? What might be the challenges around, you know, addressing those things? And is there anything in the pipeline that you guys can talk about that you might be working on? We don't sort of want any sort of, you know, breaking news as such, but you're thinking going next.
So yeah, quite a broad answer to start with. Audio isolation is kind of in its infancy compared to like sectors like aerospace or precision engineering, where like a simple mistake can lead to a critical error across the board. So as these advancements develop in those sectors and the awareness for hi-fi isolation becomes a lot more prominent and people are willing to invest more money, we would hope to start integrating stuff from different fields into this, particularly like aerospace, where it's super advanced. We want to kind of bring this into the fold and start developing as stuff advances.
Yeah, no, Josh hit a really good point there. I think in terms of like the industry as a whole, I think there is, like Josh said, it's in its infancy. I think there are going to be a lot of exciting products from new companies. And I think the whole, as an industry, it's going to advance. We don't know what's around the corner, but I'm sure there'll be some interesting technologies. So yeah, I think, like Josh said, touching on aerospace, we're working with Vaclav, who helped tune the mat, and he works for an aerospace company, and he heads up a team where they kind of basically troubleshoot vibration issues. And having him part of the team has been a real help because he brings new insights, new education to us. We're not looking to replace the Alva or the Alva EQ anytime soon. But what we're fundamentally trying to do is just get a better understanding of the vibrations in different systems, because systems, speakers, rooms, they're all kind of act very differently. And we want to build up a database of all these varying different rooms and and speakers, so we can use that data working with VacLab to better tune devices in the future. So right now, our development is mainly in research and building our in-house testing capabilities, which VacLab helped. He wrote some custom software for us to properly test things. We've invested heavily in accelerometers. So fundamentally right now, our core is just to better understand vibrations and how they influence sound. And then from there, with that new information, then we'll kind of work on more advancing technologies.
Yeah, brilliant.
Yeah, I'd love to piggyback off of that, because I would love to understand what process you go through when you're designing your isolation products, especially like your speaker isolation products. And if I can do a twofer here, if you don't mind, like I'm almost wondering, where do you start, right? Like how important is speaker isolation compared to other component isolation if you're just getting started down the road of isolating your products? I think sometimes the big question is, where do you start? And then what you should be looking for as you're introducing isolation products into your fold. So I'm sorry for like a twofer, but I want to piggyback off of the level of effort that goes into designing your products, but then also where should someone start if they're just getting into isolation?
Yeah, so I mean, I'll answer the second one because it's probably the easiest. I think speakers tend to be the best place to start. I mean, we often suggest to customers just try a set of Alva EQs because they're a low entry price point, and it gives someone a taster of what proper isolation can do. But speakers are the largest source of vibration in almost every room, and you kind of want to kind of isolate it at the source, because then it will still, if it's not isolated, it will still permeate through the structure of the building and into the equipment. So I think speaker isolation is the most important. It's the biggest driver of vibration in the room. In terms of designing products, everything with vibration it all starts with actually understanding what vibrational frequencies you're dealing with. So we'll use accelerometers and a DAQ, which basically just converts that signal into digital format. And we will measure multiple different systems to basically understand the vibration levels, and then we'll draw kind of like this envelope to say, like, these are the peak vibrations, and then we'll work like hell to try and bring those down to a lower level. So it starts with data, and then a lot of the process is listening, because with essentially you can't what you measure is not always related to what you hear, but so we'll do a lot of measuring to understand the vibrations, and then we'll also measure the isolator itself. So we'll have an accelerometer on the speaker and then also on the floor itself to measure how much vibration goes through, and then we'll listen to it. That's a bit of a short, maybe too technical explanation, but that's kind of the process that we go through, and just keep reiterating it until we get to more acceptable measurements that deliver a good improvement in sound.
I mean, it makes a lot of sense, Theo, and I don't mean to turn this into an ad, and I hope that the community doesn't take it this way, but I have virtually every product that you manufacture today integrated into my system, and I will echo that. I think the biggest night and day difference was going to put the OVAs underneath the speakers and hearing the difference in the room. I mean, it was almost like I bought a new set of speakers. It was really a drastic change. I think in my review of the product, I was referring it to like if I changed out my turntable or I changed out my amp. It was that drastic of a difference of an upgrade in sound quality. So while they might be a little bit more pricier than the EQs, I think what you're introducing, if you've invested a decent amount of money into speakers, I think you deserve yourself to consider at least experimenting and using your products underneath of them for isolation and taking advantage of the money back guarantee that you offer. Because I have a feeling people are going to notice the difference. I recorded an A/B difference on mine, playing 2 different tracks with and without your isolation, and people heard the difference. And that's translating through YouTube, through the compression, through everything else that it's doing to murder the sound quality, and people still heard the difference. Shane, I know you know what I'm talking about, because we've had numerous conversations how drastic the difference is with speakers sitting on the stack audio isolation.
I mean, I've got $100,000 Wilsons in my room. You're not meant to be able to make those sound any better than they already do. The 2 boys down the bottom here have made a way of it happening. I mean, that reaction video I did was absolutely I mean, I still had the sweat on my brow while I was moving those speakers back into place, and I just went play and went, holy heck, what the heck's happened here? Because I had tried everything before I tried the Stack Audio products, and they are, and again, I'm not meaning to make this an ad. We are fans of the brand. Hand in the air. I'm not. That needs to be said, right? But we also know that these young guys, we're bringing them to you, our audiophile community, because they're young, fresh minds with a different take on isolation, and it is paramount that you get it right in your system, because I can talk about a $500,000 system in my room, and they have transformed it by literally being able to isolate everything, playback design stuff, everything that I've put things under has improved the presentation, and everybody that contacts me, I might say, that's trusted my reviews on these products have got back in touch with me and said, yes, Shane, what you described in your review is exactly what we heard when we put them under our system. So,
Same.
yeah, look, and I know Louis feels the same, and we're just so happy to have you guys here. I think we've probably peppered you with enough questions. I want to get this out as soon as we can to our great communities, which I know Louis and I both love very dearly, and we treasure their input, and we hope we get lots of input back on this video so that we can talk to you guys. And by all means, guys, chime in if you're watching the comments and you've got something to say. Get on board. And,
absolutely. Yeah, it's a good idea.
Help us out, because you guys are the as far as I'm concerned, are cutting new ground in this area, and I'm very, very happy to have it all underneath my system, I can tell you.
Well, thank you very much for your kind words. Yeah, thank you.
Well, we'll see you guys on the next episode of the Audiophile series. Shane and I will be making that announcement here very soon on who our next guest will be. We want to thank the community for joining us, and of course, the Stack Audio team for joining us today. Really appreciate y'all being on the program, and we'll see you next time.